Matter Energy 2, Evidence Number 1, Part 2. In the first problem, we are asked to get the frequency and to get the period. Frequency will equal 1 Hz and the period will be 1 over 1 Hz. In the second problem, we have to get the speed if our displacement is 1 millimeter. To get the speed, we will multiply 2 times p times frequency times the amplitude, which is 2.2 millimeters. Now for that we have to remember that since we're going to be doing this in meters, we have to convert those 2 millimeters into meters. We will get 4.1469 meters per second, and that will be our speed. In the third problem, what we have to do is to get the work that the compression force does on the spring performed and what is our potential energy that is acquired by the string. So for the work, we have to use force times distance. Now our distance, once again, is in millimeters, so we will have to convert it to meters. And our force will be 190 newtons per meter. Our result will be 6.65 newtons per minute. Afterwards, we will need the formula to get our potential energy, which is 1/2 of the force times the distance squared, and our result will be 0.116375 newtons. On our fourth problem, we are asked to get the speed of a transverse wave along a wire. So we have the mass of the wire, which is 1/2 kilogram or 0.5 kilograms, its length, which is 1/2 meter or 0.5 meters, and we have the tension, which is 100 newtons. Now what we have to do is divide our mass by our length. We have a result of 1. For our speed of this transverse wave, we have to get square root of force over our previous result. It will be 10 meters per second. On our fifth problem, we are asked to find the mass of a rope. We have its length, which is 4 meters, and we know that it is subjected to a tensile strength of 300 newtons, while maintaining a shear wave speed of 150 meters per second. So we already have the speed. Now we will use that formula to get the mass. And once we have gotten our mass, it will be 0.05332 kilograms. On our sixth problem, we are asked to get how much time it will take for the sound to travel through a piece of road. So we have a specific formula for that, and we will use it. It is equal to density is being divided by y. Our result in here will be 3646.293262 meters per second. And afterwards, we have to divide that. We have to divide 2.5 meters, which is its length, over our previous result, and our final result will be 6.856277925 times 10 minus 4 seconds. On our seventh problem, we are asked to get the intensity of a sound. And for that, we will use the formula for intensity, in which we're asked to get a logarithm, and our final result will be 3.162277 times 10 minus 5. On our 8th problem, we have a car with a radio, and we have our frequency, we have its linear speed, and we have a receptor that does not move. So we are asked what will be the frequency once the car moves away from our receptor. We are asked to get the frequency of when the car comes closer and when the car goes away. We will be using the formula for frequency. We'll be using it twice, but the only difference will be that it will be FO times V times VF over V. But the only difference will be that in the first one it will be a plus sign, and in the next one it will be a minus sign, because the car is coming closer or coming away, but the result will be practically the same. In our 9th and final problem, we have a city subway. Once again, we have the velocity 72 kilometers per hour, and we have this frequency, which is 330 Hertz, and we once again have a static receptor who does not move. We are asked what will be the frequency of the sound when the observer hears a metro pass by. So we have two frequencies once again. The first one when the metro is coming closer, the second one when the metro is going away. We will once again we will be using a slightly different formula in here, but it's the same. Like in the first one, it will be plus because it's getting closer. In the second one, it will be minus because it's going away. And the results will be basically the same except for our sign. And that will be all. So thank you.